Hello, hello. Can you guys all hear me okay? Yeah, okay, so my understanding is if I'm too loud, there's like a little dial on one of the ears to turn it up or down. If I'm going too fast, there's a little dial on the other side, it'll slow me down. But that'll probably cut into drinks, so you probably don't want to mess with that one. All right, how many of you were here 2 years ago when I spoke about the power of an aggregation pipeline? Like 5 of you. The rest of you hadn't heard about MongoDB at that point? All right, so what I'm going to do, sorry to the 5 of you who were here and remember it, I'm going to do like a 5-minute recap of everything I talked about in an hour and 15 minutes 2 years ago that I'm sure you guys remember. So, it was 2017, and that was the talk. So, I talked about pipeline power. What the heck is an aggregation pipeline? Well, we actually talked about data in general, how what you do with data is you store it in the database, you get it out of the database, right? And sometimes you don't know exactly what format you're going to want to get it out of the database because, well, you don't know all the different types of queries you're going to run on them. So we could pre-aggregate our data, or we could aggregate the data elsewhere, like with, I don't know, Spark or Hadoop or whatever, or you can just aggregate right there in MongoDB, which is, of course, my recommendation. Then we talked about home improvement projects and how I don't like to drive all the way to the store to cut a piece of wood, and I just like manually cut it at home, even though it takes longer, like maybe 30 seconds instead of like a fraction of a second, but I don't have to drive anywhere. See, that's an analogy for your data. If you have to move your data somewhere else to analyze it, maybe the analysis is fast, moving the data back and forth, it's slow, and it's expensive. So let's not do that. We talked about a pipeline or a pipe. Why do we call it pipeline? It has nothing to do with the pipe. It doesn't really even have anything to do with this pipe. It is just like the Unix pipeline. How many here use command line stuff still? Good, good. I would totally lose all of you if you were not into that sort of thing. So MongoDB document pipeline works exactly the same way, right? You take your documents and they go through match and group and sort, and except that your input stream is documents and what comes out of it is also documents, right? So we use the little train to represent what a pipeline looks like and what the different stages are. What can go into a pipeline is contents of a collection or contents of a view or maybe a special system stage. Each stage is expressed as JSON, squigglies everywhere. And then we looked at a really simple example. So here we have 3 documents, and first we match just the documents where language is English. Oh look, only 2 documents go through that pipe. Now we're going to unwind subjects. Remember, unwind, this is supposed to be an advanced talk, so sorry if this is all brand new to some of you. Unwind will flatten or unwind the arrays and create more documents, right? So now each element of an array has its own copy of the document. Then we might want to group by something. Let's just say, oh, I don't know, subject, and count how many there are in each. And then maybe we'll sort by count, and then maybe we'll do like a limit, a project, skip, whatever. That's a basic pipeline. With me so far? I hope, because we're barely getting started. And we talked about different stages and how stages can be thought of as having a different effect on the documents going through it. Right? Some reduce the number of documents going through it by skipping or filtering out. Some transform them completely into different shape. Right? We talked about explain and how you can tell what's actually happening in your pipeline, which is by running an explain on it, just like any other query, and seeing how, oh, here, a cursor with this query is the source for the documents. Right? We then talked about a really important concept called streaming versus blocking. Streaming is when you look at the first document and it can go through all these stages without waiting for the other documents until it gets to group. You can't really continue after group until you've seen all the rest of the documents. So 2 of the stages are special. Sort and group are blocking stages, meaning that when you get to that stage, you have to stop and you can't continue until you've seen all of the incoming documents. Right, and that makes sense, right? If you're sorting a list and you're supposed to put the highest thing first, you can't send anything down the pipeline until you've seen whether the last document might actually be that highest value, right? Why is this important? Well, if you only have streaming stages, this is roughly what it looks like when your documents go through it. Oh, look at that. The first batch of documents, we actually don't do them one at a time, we do them a batch at a time. Goes all the way through and you start seeing results. And notice that we didn't really use any extra resources. What happens if you have a blocking stage is we actually have to accumulate everything in a grouping stage or a sorting stage, and that's what uses up RAM and sometimes may need to spill to disk. So this is how you can tell, where the slow parts of the aggregation are. We talked about expressions. We actually have a lot more of them now than we even did then. I kind of like to divide them up into groups by the type of operations they do. I like to focus on array operations. Why is that? Well, you're all using MongoDB, which means you like the document model, which means your data is not flat and tabular, which means you probably have arrays in your schema, right? If you have arrays, you want to be able to still do powerful analytics without having to flatten them every time. And so I gave some examples about all the different array expressions that let you do powerful analysis. There's a recording of the talk, and there's a GitHub repo with all the examples that's still there, so don't worry about trying to, take a picture and squint at this stuff. I gave some readability tips. We talked about performance, sharding, streaming versus blocking, how it works there. I gave an example of schema discovery and schema transformation. And then, of course, we always finish the talk with a very fancy kind of a windowing function example with network suspect activity detection, I call it. But basically, you have a collection where every document represents a sign-in from a user from a particular IP address, and you have lots and lots of them, and you say, well, I want to know during, let's say, this 3 months period, in a 10-minute window, did any user log in from more than one different IP address? Because that probably means they're sharing their account with somebody else, which we don't want them to do. This was an actual customer request, can we write an aggregation pipeline to do that? And I said, of course you can, and it's really simple. But it was much simpler during the talk because we kind of broke it down and we did it step by step. Those of you who were there, it was really simple, right? At the time, it seemed really simple, right? I'd just say yes. All right, so that was the repo for it, still is. So we talked about understanding how stuff works, understanding expressions, using functions for readability, yay. And we talked about what the future of aggregation would be. And I promised a bunch of stuff for the future. Let's see how we did. So we're moving back in time. We're moving to 2018. And in 2018, right here, in the keynote, I actually gave a demo of the aggregation pipeline builder in Compass. Now, that doesn't add any new functionality to what an aggregation can do, but it does make it a lot easier to debug your aggregations, right? Because it shows you how, at the end of each stage, what are the documents that are coming out of it. Makes it a lot easier to build the next stage and the next one. Even I sometimes need help debugging these things. All right, so then, what else? So we have Compass Builder for aggregation, like I promised. Now, we always have performance improvements and optimizations. That's in every release, right? That's not something that we go, oh, for the next release, we're going to make it faster, but never again, right? We're always trying to improve performance. More stages and expressions, of course, we've been adding pretty much in every release since. I'll probably end up mentioning some of them. And that left a couple. Now, what do they even mean? So I actually had somebody come to a booth today and say, how come you have different languages? Like, I have to learn one language for find and another one for aggregate. I said, oh, you think it's just two. What about that language for update? That's yet another language, right? So we've sort of had as a goal for you guys not to have to learn too many languages. And if you've ever seen my aggregate is the new find t-shirt, you know that I think everything should just be an aggregation. And I'll show you where that's going. And more options for output, we happen to have some of those done for 4.2 as well. So first, unify different languages. Now, when I was here with this previous talk, I think 3.6 was about to come out, or maybe had just come out. And 3.6 allowed you to use aggregation expressions in find expressions. So prior to that, you couldn't say, find me all the documents where field A is equal to field B. Because the syntax of regular find expressions was where this field is equal to this constant value. There was no way to plug in an expression there. So what we allowed you to do is to have $EXPR, which could be ANDed or ORed with other regular find conditions. And it could use pretty much any aggregation expression. So you could say $EQ, value of A, value of B, or like here, the example that I've used was, let's say that in every record for particular people, there's an array of their children, right? And within that array, you have the name, date of birth, and whether or not they're a dependent. Right? So now you could query and say, okay, find me any record where input is children, and if their date of birth is less than a certain date and dependent is true, right, then it's going to put true in an array, and any element true says if any of their children satisfy these two conditions, then return me that document. And then we're going to, set audit true. Now, the funny thing here is that it kind of looks like you're using an aggregation here in an update, but of course you're using it in the query portion of an update. That's not really an update, right? So, aggregation, sure, it's like we just go, you can add fields and project a new field that says number of children, size of the children array, or number of dependents, size of the children array, but only counting the children where dependence is true. Cool, advanced aggregation expressions. Find, like that example that I just showed you, right? If the number of children is less than 2, right? That's a match condition. And then in an update, you can do this fancy update, except that you're cheating. You didn't actually use aggregation in the update part. And it's true, because until 4.2, you couldn't, right? And just as a refresher, an update has 3 parts, roughly. There's the query part, that's the predicate, right? That determines which documents we will consider to apply the update to. Second part is the update. That describes how you want to modify or mutate this document, right? And then the last one is options, and that's when you say things like, do you want to upsert or create a new document if there is no match, or do you want to multi-true or not, meaning do you want to update more than one matching document or just the one? The only part that's changing for 4.2 is the update part, so that's what we'll talk about. And the important thing to remember is everything that you used to do before 4.2 will still work. It's not changing at all. And what could you do? Well, you could say $modifier. So $set some new values. You could do $inc, right? Increment by some value. $push, add to set. All of those are still the same. The other thing you could do in an update is if you didn't use modifiers, let's see if the little pointer works. It doesn't work. But if you didn't use modifiers, if you just said field value, that would indicate a replacement document that's going to replace whatever was there to begin with. Not changing at all. If you specify a document for an update, it'll be interpreted same as the old one. However, if you specify an array, which previously would not have been legal input in that field, in 4.2, if you specify an array, that means you are specifying a pipeline that will define how the document will be transformed from its current shape into the new shape. Make sense? Sounds pretty powerful, right? Because aggregation pipeline is so powerful. However, I fibbed a little bit. When I said you could use the whole pipeline, I didn't actually mean the whole pipeline. What I meant was you could use any stages that transform one document to one document. So a document to a different shape of the same document. And those are those 3 stages, right? You can add fields to an existing document. Project says I'm going to define all the fields. Here, actually, it only makes sense to use project to exclude fields or unset them. And replace root says I'm just going to define the whole new document. We gave them aliases so they would be more confusing, so you could try to confuse them for the old update. But remember, if it's in the brackets, it's an aggregation, and $set just means I'm going to add some new fields. $unset says I'm going to unset a bunch of fields, and $replace with is like defining a new replacement document for it. And you can have multiple stages, so you can make things more readable by, splitting it up into multiple stages. What comes out at the very end is the thing that's going to be applied to the document being updated. Let's look at some examples, because that's probably the easiest way to see how exactly things work. So I'm going to take a perfectly ordinary update that you can currently do with regular update, and show you what it looks like in the new aggregation pipeline syntax, and then we're going to see what fancy things we can do with it that we wouldn't be able to do with the regular update. So this says find a document with _ID value 1, so there's only going to be one of them. Increment field A by 1, and if you don't find a document, create it. Pretty simple, everybody's seen an update like that. I have a whole bunch of examples on the left of what the original document might have looked like. And then on the right, we're going to see what the result would be of this update. So if _ID didn't have an A field, then A field would be created with the value 1, because when we increment a non-existent field, it's like incrementing 0. The next one, not surprisingly, we'll see 11, 101. If the document didn't exist at all, it'll be created with this ID and A as value 1. And do you guys know what happens with that last one? When A is not a number, you're going to get a root error that says you cannot apply increment to a value that's not numeric, which of course makes sense. So what is the equivalent pipeline for this type of an update? Well, I'm just going to do brackets and then $set, which is like add fields. I'm going to add a field A, which is going to be the sum of the value of A and 1. Exactly the same meaning. Should have exactly the same effect. And it will until you get to here, where you might notice that in aggregation, $sum actually ignores non-numeric fields. If you want to get an error if the field is non-numeric, you would use $add. Aggregation's kind of funny that way. So if you do add, it'll say, oh, sorry, add supports only numeric and certain types of dates. So cool, great. What else might we want to do? So you go, well, I could already do this, before. I'll say, well, there's a request I've seen in our Jira system a bunch of times where people say, well, is there any way to do an increment but start with something other than 0 if the value doesn't exist? Like initialize it to some other value. So let's say that if they just started, let's say these are scores in a game. If they just started playing, you want to start them with 20. Great. So we want to set A to something so that in those cases where A didn't exist or the whole document doesn't exist, that it would be 21. How would we do it? Well, aggregation's pretty powerful, and it lets you do conditional things. Like you can say if type of field A, meaning the field A that exists in the document I'm modifying, if the type of it is missing, if it's not there, then I'll make it 21, otherwise add 1 to $A. Makes sense? I see a lot of heads nodding. This is good. That means we can keep moving. What if I want to get fancier and say, you know what? I don't ever want a score to go above 100. So if they get up to 100 and they try to increment it again, I just want it to cap it at 100. That's pretty easy. We have a $max expression, or a min expression in this case would be the more useful one. So I would just wrap the whole thing in min of 100 or the entire value that I wrote before. And now sometimes I have this weird, improper field, and I'm using some because I don't want an error, but I kind of want to know later, what field was incremented when there was a 1. So I might get fancy and say, I want to save the value of the field that I'm changing in another field. So I'll say, and set prev A, previous value of A, to what A has now, and this is what I would get. If A was missing, previous A is missing as well. Now this actually has a pretty cool application because sometimes people go, hey, I'm using change streams and I see when a new value is set, how can I find out what the old value was? I go, well, you could set it. You could set some field to the old value, except you couldn't do it atomically before because you couldn't use a value from the document itself. Here you'd be like, I'm going to set A to a new value and I'm going to set A previous to the current value of A. And now whatever is consuming that change stream can actually have both pieces of information, which they tell me for whatever reason is very useful. All right, here's another use case that you can use this type of update for, which is kind of cool. So let's say for whatever reason, you decide that you want to set defaults for certain fields if they don't exist in the document. Let's say that you say, well, if the field A or B doesn't exist, we want to set it to 0. And if C doesn't exist, we want to set it to a string that says unset. And look how easy it is when you can do this type of an update with an aggregation pipeline. So these are my example documents, and you can see that all of them have some 2 out of 3 fields. We can do a multi-update specifying a replace with, but that replace with will contain both the new defaults and the existing values, because we're going to use merge objects, which takes an array of objects and it kind of smushes them all together. And if a field occurs in a bunch of them, the last one wins. So what that means is if we put the defaults first and then $root, which refers to the entire document second, I see some minds being blown here in the audience. What you get is the exact thing that you wanted, which is the default fields I'll lay down, then the existing values overwrite them, unless there are no existing values, in which case you get the defaults left. This is pretty handy. Yeah. Please don't applaud. Hold the applause to the end. All right, and then this is the trickiest one that I left to last, because this one is a little involved, but this is one that you may have seen in our JIRA system with titles like, why can't I upsert an array inside of a document? Or how can I set something but set it differently? How can I do a set on update that's different from a set on insert? And I've reduced it to sort of this type of example. So let's say you have like an IoT-ish type of data model, right? You have some sensor maybe that's sending in a bunch of data, and every document that comes in looks something like that. It just tells you for this ID, for this day, and this hour, this is the value. And then the document on top, that's the accumulated values for, let's say device ID 1, for a certain date, there's an array of hours, and that array, for every hour that we receive data for, has, the value of the hour and, the value of the metric. So I get this new thing. I want to see, do I have an ID and day that matches it? And if I do, then I want to, either add a new array element or add this value to an existing array. And now you're thinking like, there's no way to express this in an update. And it's true, in update language, there's no way to express this. But you can express this in a pipeline, a fairly short pipeline, really. So first of all, you want to match a document that has ID X and day Y, and hopefully you have a unique index on it, right? Because otherwise you might have duplicates that you'd later have to add together. And you want upsert to be true, because if this is the first metric for that device in that hour, you want it to create the document. But if a document already exists, you don't want to create it again. So the tricky part, of course, is if we find this document, what do we set H to? I'm giving you hints here. So the main thing is, does the hour that I've just reported for, does it already exist in the array or not, right? That's the main kind of dividing line. If there isn't an element for my hour, if hour Z, or Z, as you say here, is not in that list of hours, then we want to add it. If it is there, then we want to transform that entry. So we're going to say $in is the aggregation way of saying is something in another something. And if Z is in h.hour array, and the reason I need that if null there is because in is going to barf if you give it a null when it expects an array. So if h.hour is empty or evaluates to nothing, then you want it to really evaluate to an empty array. So if Z is in there, then we're going to do something complex, else we're going to do something simple. And the simple thing is we're just going to append this new record to this existing array, which if it doesn't actually exist, exists as an empty array, right? Heads nodding, this is always good. So then how do we transform that part of the array if it does exist? We use $map. This is why I had to do a quick review of the previous talk, right? Because the powerful array expressions include things like $map, which iterates over all the elements in an array. So your input is $H, and what you want to output is conditionally, if this element that I'm looking at is not the hour that I care about, then just pass it along. $, this says the current element. But if it is that hour, then create this new element, which is hour Z. Value is the sum of the value that's already there plus my new metric that it just came in. Wow, that seems so simple when I put it like that, right? You all would have been able to figure this out on your own. Luckily, you don't need to, you got these examples. So as a recap, updates can be specified with an aggregation pipeline, but if you use the old syntax, it'll work perfectly. All of the fields from the existing current document, the one that you're transforming, can be accessed. This is the really powerful part of it, and this is the part that was never available before. Now it's going to be slightly slower, but if there's something you need to do that you couldn't do before, you can do it with this now. That's pretty powerful in my book. All right, so that's cool. We can knock unifying different languages off of our to-do list, except for, all the other unification that we still are working on. What about more options for output? Who wants more options for output? Yeah, me too. I was begging for that one for a long time. What could we do before? Well, since like 2.6, I think, you could do an aggregation, and then on the last stage specify $out and the name of a collection, and the result of your aggregation would be written to this collection. Now, the collection can't be sharded, and if that collection already exists, we're just going to overwrite it with the new one. So it was a little bit limited, but still, it's kind of like what traditional databases called materialized views way back when. So I actually think we missed a marketing opportunity back in 2.6 days to say, we support materialized views. You can just materialize the result of this aggregation into a collection. And it's true, it just wouldn't work sharded. Right, so here's all the restrictions. Must be unsharded, overwrites existing. So we added a new stage. So $out still does exactly what it did before. At first we were going to modify $out, but then we thought maybe that'd be confusing. So instead we just added a new stage called $merge. And $merge is kind of like $out in the sense that it needs to be last in the pipeline. It'll do something with the result of the pipeline. But what it can do to it is put it into another collection where that collection can already exist and it won't be overwritten. It can be in the same or different database. And it can be sharded. Whoa, awesome. What can you do with all that? Well, first, let's take a look at, the basic structure of it. So you say $merge, and then you specify into, and then the target. And the target could just be a collection name, in which case it'll be a collection in the same database. Or it could be a structure that says database such and such, collection such and such. And then there's a field that says on. Now, the whole concept of merging only makes sense if we agree what is it that we're going to be merging. Like, how do I know this result? Should it be merged into some existing record or be its own new record? So on is the thing that tells us which fields to compare to decide if the record is the same or not. Now, you don't have to specify on. On is actually optional. And this is because by default, we're going to assume that what we logically call the document key, _ID in an unsharded collection, and the combination of shard key and _ID in a sharded collection identifies a document uniquely within our system. So if you don't specify on, that's what we're going to assume that it is. If you do specify something else, the only requirement is you have to have a unique index on it. This is so that we know that we're correctly only updating a single record and not accidentally not updating a bunch of them. So ID or shard key and ID combination, it must be unique. Now, the other fields that you specify in merge have to do with what action you want taken. And I kind of want to discuss those actions in abstract sense, right? If you have documents coming from a source collection into a target collection, you might want to replace the matching documents, or you might want to, add the new fields from the new document but leave the old fields alone, right? You might want to specify some sort of a custom way of merging them, right? And in all cases, you get to specify an action if nothing matched, or if something matched. So if nothing matched, by default, we'll do what you would expect, which is an insert, right? So if we have a document and let's say the underscore ID doesn't match an underscore ID in the target collection, we'll just insert it. That kind of makes sense. If there's already a document with an underscore ID there that matches this underscore ID, we kind of went back and forth. What's the most logical thing? Well, probably either replace the whole document or update the existing document with the fields of the new document, which is what we decided was the logical thing. We updated, which we actually call merge, right? Merging the fields from the new one into the old one. If any fields are the same, the new one wins, right? Just like when we did that merge objects in that other example. So that's called merge, and that's the default. So really, the only field that's required for $merge stage is into. We're not going to guess which collection you want to output your results into. That you have to tell us. Everything else, we can use the defaults. So on can be default underscore ID or shard key ID. When not matched, the default is insert. When matched, the default is merge. The other actions that are available. When not matched, you could choose to discard the document, or you could choose to fail the pipeline. Now, when does that make sense? If you're doing, let's say you're sourcing something from another, source of data about your users. Let's say they're, I don't know, some linked Facebook profile stuff. And you go to merge it with their profile and you don't find a match. You might go, well, either it's data for some user that doesn't exist in my system, I don't want to create them, so I just want to discard it. Or if the user must exist, this may be a sign that there's a logical problem with the extract that you're trying to import from, so you might want to fail with, on your error, like, hey, I expected to always find a record here, right? When matched, you could, rather than merging or updating the document, you could choose to replace the entire document. You could keep existing, meaning ignore the new one. If there's a document already there, just leave it alone. You could fail. And this could be in a scenario where you might be appending to an existing collection and you don't expect to find any matches. You expect the appended version to be, non-overlapping with the data that's already there. Finding a match could mean you're accidentally reprocessing a batch a second time or something like that. But that last one, the brackets with ... that's actually the most interesting one because you can specify your own custom pipeline for how the document should be merged, the existing and the new document. So, what that pipeline lets you do is reference existing document fields and the new incoming document fields, and then you can specify pretty much any pipeline, any sort of transformation combining those two fields. So you could say, when matched, you can add a field total, which is a sum of the existing document total and the new document's total. You don't want to overwrite the field, you don't want to replace the field, you don't want to leave the field. You want to logically combine the values that are in there. So you pretty much can do any kind of transformation at this point with custom logic that you invented. And of course, we'll use $set because that sounds better than add fields. New refers to the new incoming document. The $total, that refers to the document that's being updated, essentially. So it's very similar to the update examples that we already looked at. You learn one language, you get two powerful abilities. Woohoo! So here's an example. So let's say that your target collection has user ID 37, and you have a new incoming document looking like that. And if that's your pipeline, you're going to add 64 to 245, and F1 is going to stay exactly as it is, because you chose to ignore that in your custom pipeline. On the other hand, your pipeline might be like this. You might say merge the whole new document, but picking up a new sum, which is a sum of the old value and the new value. And now the exact same thing, F1 will be the incoming field rather than the original field. You could also choose to concatenate them or do whatever else you wanted. Or you could keep the one that's, I don't know, higher value or longer, or these are dates. You might want to compare dates and say, if what I have is newer than what I've got incoming, ignore it. Otherwise, overwrite it, right? These are all kind of logical things that depend on your business logic. You can also use an optional let, and this is when you're building a custom pipeline, you might want to name your own variables. It's never necessary. It may just in some cases be more readable, because you can always refer to all the fields. Essentially, new is set to root. That's like the default let. If you do your own let expression, you will not have new to refer to unless you define it yourself. So if you do something like, let I total is total, right? You can refer to I total then, but you couldn't also refer to $$ new because it's not defined. So just a little mention there. All right, here's a simple example. I want to append from some temp collection where I do some massaging and data validation, and when I'm convinced that it's all nice and cleansed, I append it to an existing master collection of verified data. So I have some pipeline, and then I say merge into data. When matched, fail, because that says I don't expect to find a match there, otherwise something's gone wrong. That's it. That's like a really trivial looking example, isn't it? But that's all it is. It's kind of similar to, insert into table, select from another table. Can't believe we didn't have that for so many years. You can also use it to do something like maintain a single view, right? You have your users, and then you're pulling data from other places. Let's say, hypothetical example, some service called mflix and another database called mfriendbook. I have no idea where those names came from. And you have your single view users. You might do some kind of projection to, rename fields to whatever you want, and now merge into single view database collection users. When not matched, discard. So I'm saying I don't want to create a record just because I found something about them somewhere else. I only want to do this for the users that I've already created. And by default, it's just going to add that field in there like an update would. And then exactly the same thing for mfriendbook. And when I run that, it's going to add another field. So every time I run this, it's going to update it with the latest whatever that I have from some other system. Of course, I could have more intricate logic, checking, do I already have an update based on that date, et cetera, et cetera. How about an example where you do roll-ups? Who does roll-ups for analytics type of reporting, right? You have certain detailed information. You want to roll it up into hourly or daily summaries so you can query them faster. So I used the MongoDB registration because I was coming up with these examples right before MongoDB World. I said, so let's say that you have a long table of registration. So every registration comes in, generates a new record, and I want to have a summary that shows for every day, for every event, how many people registered for that event. So first of all, I'm going to create a unique index on event and date combination because that's going to be my on fields. And then I'm going to say for event MongoDB World 19, I'm going to group, and my group is going to be the date in a particular format. And then I'm going to get the count. I'm going to use project to reshape that output document to just have event, date, and total. And I'm going to merge into reg summary on event and date. Now, that collection doesn't exist. This is the first time I've ever run this. So it's going to take all of the days that exist up till now and come up with some result. Now, I might have run this partway through 521. So maybe the next day I'm going to run it again for the previous day only and overwrite the previous total with whatever the cumulative total that I now know now that the day is over. Or I can run it for any arbitrary day or range of days. So here I'm running it for 522. And I'm just going to count the total, add the fields for the date that I'm running it for the event I'm running it for, and merge it into reg summary. And then I'm going to have a new entry there. Pretty easy. The nice thing here is you don't have to reanalyze or reaggregate the entire thing. You can do just a slice of data that's new since the last time you ran your aggregation. So This is amazing. We got 3 minutes left. Shocking. So aggregate is the new find. What I mean by that is we're pretty much trying to move everything to have a single language. That single language is going to be the aggregation pipeline because it's the most powerful way of transforming things. And so yeah, the sooner you learn it, the cooler it'll be for you. Shall we take some questions? What the heck? We don't usually have time for questions at the end, but
I know this is unheard of. Right, we've got
yeah,
about,
if you guys want to take a deep breath.
you can have 4 minutes, so we can go for beer now.
4 minutes. My clock must be.
Any questions, guys? Arms
Any
up.
questions? Any
Gracia.
questions?
Or is the thought of a drink far more important?
Yeah, I mean, if you want to go and get in line for the drink early, and by the way, if you have a question and you don't want to ask it in front of everybody, I'll be around out there. Just find me with your question, and I'll make up some answer. Yes.
Using the aggregate pipeline in the update, is there any performance difference to doing the same in the actual aggregate?
Yeah. So remember I had a little thing that says not as efficient, but much more powerful. So I'm ashamed to say that we do not yet have the smarts in the system after the pipeline to figure out which fields were not changed. And so we write the whole document into the op log. Yeah, we totally sucked there. That's a project that's really high on the backlog for 4.4, and we're going to backport it to 4.2 as soon as it's done. But yeah, it's essentially the code that existed already couldn't be reused because the transformations are very different in form, and you have to actually do an analysis of it. So probably for the really simple cases, it'll be easy to fix, but for some of the more complex cases, it may not be quite as easy.
But is there any performance difference between doing it in the .update versus doing it in the .aggregate with a merge or an out?
So let me just put it this way: if you're on a standalone without replication, it won't be noticeable difference. It will be pretty comparable. However, everybody's running a replica set in production, right? Everybody nod your heads, or I'm going to get really mad. And so that means you care about how much stuff is being written to the op log. Normally, we optimize the op log entries to only include the actual changed fields, which means that, if you have a giant document and you only change a couple of small things, you want a couple of small things to show up in the op log, not the whole document. So for large documents, there may be some replication inefficiencies associated with these updates, at least until we fix them. Way to make us bring our dirty laundry out in front of everyone. But now that I said it, the pressure to fix it is going to be higher. So I did it on purpose.
Any other questions?
I think there's a hand up.
Son, I'm over. You can't hear me. You haven't got a head. Oh, well.
Oh, there's another mic making its way towards you. And then we had one more in the middle there, and then we'll go drinking.
Hello. Yeah, can we use rename in this update?
Well, $rename is a modifier in update. It is not a modifier that exists in aggregation. You have other ways of doing a rename, right? You can do a $set and a $unset, right?
Okay.
So for those who don't know, $rename in an update changes the name of the field. So you do $rename, some field, some other new name. The same way you could do it in aggregation would be set the new name to the contents of the old name, unset the old one. So you can achieve the same thing, but $rename as a modifier only exists in the update system.
Thank you.
Mm-hmm.
Right, we had one more. Oh, more questions.
Oh, now
Just
everybody.
Just go for that one there.
Hi. So with all the aggregation pipeline, what's the driver support like? Because I know the C# driver isn't so great for doing aggregations.
What? That's because in C# you guys expect link support for everything because you want to build it all. Yeah. So actually, aggregation support only exists in Java and C# driver because they're the only ones that have these helpers. But everybody else just expects that you're going to write your pipeline and just pass it to the aggregate helper, right? You don't actually need it. So here, the update helper will now accept either a document or a pipeline, right? You're asking for help building the pipeline. It's
Yeah.
same as before.
Yeah,
If you
'cause
thought if you thought it was good before, it's still good. If you thought it was crappy
There's
before,
been
it's still
improvements
crappy.
with like the different expressions.
All right. Okay. So now we're going to be finished, and you have to clap louder than the other side, because otherwise, my feelings are going to be
Okay,
hurt.
so for the guys that didn't do the questions, you can catch us here outside.
Yeah, just come up, or we'll walk out. The whole circle.
Feedback. Massive round of applause. Go.
Thank you.